Right, well, good morning, everyone. This is quite a big talk, so I'm just going to hammer it out. There will be a lot that I won't get covered in half an hour, so feel free to pester me during breaks or over a drink. The talk is about IT, managing projects or CSS projects with IT. IT stands for Inverted Triangle Architecture for CSS. It's a really, really simple, high-level architecture for CSS that I've been working on for around 3 years now, and this is actually the first time ever I've publicly spoken about it. I've not written about it anywhere. This is the first talk I've done on it. The talk is managing CSS projects with it. It's basically a way of managing CSS at a very, very, very high level. So it's not about pre-processes, it's not about naming conventions, it's just a real high-level approach to managing large CSS projects. Because I haven't spoken about it before, I've only spoken about it with clients and workshop attendees, I'd be really interested to get your feedback whilst I'm speaking, so if you want to tweet anything about it, positives, negatives, questions, the hashtag is simply ITCSS. And a real little bit about me. I'm Harry, I'm a consultant front-end architect from the UK, which basically means I travel around, meet clients, and help them solve architectural issues with UIs. It's mainly just around CSS and design process, which is where it came from, and most of the clients I work with are product-based, they're large teams, large companies with big code bases, so it is a high-level architecture to try and help solve the kinds of problems that these companies have. It can work on any kind of project, it can work on tiny projects or gigantic ones, but it's to help teams with large projects, large code bases, manage product-level CSS much better. Before we get too far into the nitty-gritty though, I've got something I need to get off my chest. You may have seen this in the news recently. Yeah, right, I share my name with a serial killer, right, which completely sucks. I learned this when I was quite young. If you actually Google my name, the second result is Harry Roberts, a criminal, the Wikipedia page, so that's bad enough, right? I lived with that for a few years. 5 years ago, I learned that in English, the word Harry, lowercase, the word Harry, means to pester or annoy or disturb people, right? And that sucks. Then I told a friend I was coming to speak in Norway, and they told me that in Norwegian, Harry means uncouth, tasteless, and vulgar. I guess what I'm trying to say is please don't call your child Harry, because it's no fun. Anyway, yeah, so let's get on. What is it? So it stands for the Inverted Triangle Architecture for CSS. It's a sane, scalable, managed architecture. I say managed because it's very high level. It encompasses entire projects. It's a real simple diagrammatic way of looking at an entire product or project's worth of CSS. It's really, really simple as well, so don't expect anything complex or mind-blowing. One of the reasons I'm most proud of it is because it's dead simple. It's a school of thought, it's not a library, so if you don't use a preprocessor, that's cool. It's just a high-level, like a meta framework, I like to call it. It's a high-level way of thinking. It's a series of principles that you can write any kind of CSS in. So you could use less or stylus. You could use a naming convention. You could choose not to use a naming convention. It's completely malleable. And it exists to try and tame problems with CSS at scale. Does anyone here work at a reasonably large scale with CSS? Like products and long-running projects. So it is designed first and foremost to solve problems with CSS at scale. You can use it anywhere because it is just such a malleable architecture. You could use it on a single-page app or even a single-page marketing site, or you could use it like I do on large projects that might last for 3 years. We can roughly group CSS's problems at scale into two categories. There are things that CSS gets wrong, and there are plenty of those, and there are things that we do wrong. So things that CSS gets wrong, straight away the cascade and inheritance. CSS's biggest feature is probably its biggest downfall. It operates in a global namespace. You've probably all had that problem where you edit one rule set up here and it breaks something on a completely different page. Because of this natural inheriting nature of CSS, everything's intermingled and operates globally. It's very loose. That's a good thing insofar as you can view source and you can learn how to be a web developer. That's how I started. That's how I became a web developer. It's a really easy syntax to get started with, but there's no strict mode. There's no way of writing CSS well all the time other than being diligent. So you can't write good quality CSS in a certain flavor It's very, very loose. It's easy to do bad things with it. It's very highly dependent on source order. So you could have an entire project written and it could all render perfectly. As soon as you move some rule sets around, that could completely break an entire UI. So we need a way of managing this source order. It's not very expressive. So you look at CSS and you only ever see it sort of in its own context. Because there's no control flow, because it's not a programming language, it doesn't really tell much of a story, so it's really hard to get an overall picture of a project's worth of CSS. Lots of gotchas. There are just some plain weird things in CSS. And probably the most important one is specificity. Specificity is a horrible, horrible part of CSS. It can undo everything else. You could have a perfect source order, but using an important or an ID can completely undo all that good work. The things that we get wrong: lack of documentation. Documentation is boring and it's costly, so we never tend to write any. The problem is CSS really needs documentation because it's not very expressive. We need to be able to, or we should, write a lot more about it. Lack of structure and quality assurance. So a lot of clients I work with have several products, and each product's CSS is built slightly differently. So there's a lack of structure between internal teams. This leads to a lack of quality assurance, and it leads to a lack of confidence and knowledge of code bases. Mixture of abilities. This is an interesting one. I think CSS is probably the only language in a company that everybody will write. Designers write CSS. Software engineers will edit CSS. So it's a complete mixed bag of people working on that language. So we need a way of managing that. A lack of knowledge about either CSS itself or the project. So the amount of people who join projects who aren't aware of what CSS is already available to them, what classes have already been exposed, where things should be put or where to look for those things, that's a real problem. Purely cosmetic things, naming conventions, people using tabs instead of spaces, just messy stuff that gets in your way, that's not very nice. And one very specific but huge problem that nearly every client I have worked with has is phase 1 gets done, and then phase 2, all the styles just go on the bottom of the style sheet. And after phase 1, everything just gets bolted onto the end of a style sheet. You're lumping all your complexity in a part of the project or a part of the CSS that isn't taking into account source order or the cascade or inheritance. So it needs to tame these things. If we look in a little more detail about inheritance, the cascade, and source order, basically each piece of CSS is a dependency. Because every rule set has the ability to cascade information or to inherit information, every rule set is potentially a dependency of another one. I did a quick screenshot of right-click and inspect element on my website, and all of these styles here, all of those contribute to rendering one paragraph element. That's essentially a dependency tree. That happens all the time. Every time you right-click inspect element, this is your dependency tree. We need a way of managing that dependency tree on a really low level. I'm not talking about package managers, I'm not talking about those kind of dependencies. I'm talking about managing the cascade inheritance on a very, very low level. That's what it helps to solve. Looking at source order, there are several different ways to order a style sheet. The old school one, and I used to do this when I first started building websites, I'd write style sheets that loosely mirror the web page. Maybe I'd have my header styles near the top, then my type styles, and the last thing in the style sheet might be the footer styles. Now, that's quite rare these days. I don't see it that often anymore, but that's a completely naive way of structuring a style sheet because, again, it doesn't take into consideration the cascade or how things inherit. It doesn't take into account specificity and source order. We evolved and things like SMAX came along, and it's interesting, or it's probably worth noting, it's probably interesting to you, that it is not a replacement for SMAX or object-oriented CSS or BEM. This is a meta framework, so this can accept different sort of architectural principles. So BEM is SMAX deals with grouping things into types. So you might have thematic chunks of CSS, but the problem is, which way do we order those chunks? How do we write those chunks that we've managed to create? And then again, we just tend to stick it on the end of a style sheet. Now, if you visualize this at project level, this is an entire project's worth of CSS. This isn't just one partial. This is your entire rendered style sheet that goes down the wire. A bad source order and incorrect cascade and inheritance leads to something that looks like this. The browser starts at the top of the style sheet and renders that rule, and then it thinks that, right, well, this one overrides that one, and then this one, but this one up here's got more specificity, and this one down here is a much looser selector, so that undoes loads of stuff. Every time you do right-click and inspect element, you see loads of strikeouts in Inspector. That's usually because of this kind of nature of how the project's ordered. Very inefficient, and not inefficient from a performance point of view. You know, a browser won't be slow in doing this, but it's just inefficient for us. There's so much waste here. Hopping up and down and back and forth up and down a style sheet is very, very redundant. I call this undoing CSS. We're writing CSS to undo CSS we've already written. That's incredibly wasteful. We're writing more code to end up with less output. So poor source order and lack of awareness of how things are cascading and inheriting can lead to a lot of redundancy and waste. One thing I've found with it-based projects is that the style sheets are tiny, like really tiny, because there's so little waste in there. Specificity. Specificity is the worst thing. And for about 4 years, I couldn't even say this word. Magically, last year, I just one day at a conference said it correctly, and it stuck. Who's familiar with the specificity wars? The specificity wars, this idea of a really weighty selector needs overriding, so you have to write another equally weighty selector later on in the style sheet, or use an important. Specificity wars are a sure sign of spiraling CSS. It's a sure sign that things haven't been architected as well as they could have been. It doesn't matter how well crafted your source order is. It doesn't matter how well you've made things cascade and inherit perfectly. Specificity can undo everything. You can have a perfect source order, things cascade in a beautiful manner, and you put one idea at the top of a project, and it can override everything after it, which is one reason why you probably shouldn't use IDs in CSS. One really useful way of visualizing specificity at project level is what I call a specificity graph. And this is an entire project's overview. Specificity graph simply plots the location in the style sheet on the x-axis and the specificity of a selector on the y-axis. You take your entire project's worth of CSS and plot it on a graph like this, you might find you get this kind of result. So we can see here we've got some highly specific selectors. Perhaps we've got a nested selector or an important. Now this in itself isn't that bad. Where things become tricky is when you're in the valleys. And this is where the specificity wars occur, when we're in one of these valleys and we need to get over one of the peaks. So this shows us very, very sort of crudely but diagrammatically exactly where we might have problems in our project. And you can't actually plot this for real. You know, I haven't written any sort of software that will plot this in an actual accurate graph. But as a concept, as a model, I find this is a really useful way of looking at the health of a CSS project. But how do we solve this? What do we do with this information? We've realized that we've got some specificity issues, either real or potential, in these little valleys down here. We solve it by writing CSS a bit like this. We should always try and make the specificity graph trend upwards. And I say trend upwards because you might have a nested selector somewhere followed by a single depth selector, so you will have tiny ups and downs. The general trend for a well-architected project should be always trending upwards. Basically, we need to write CSS in specificity order. That's the first step we need to take to make sure that CSS is more maintainable. So this leaves us with a graph like this, and then we chunk this up. Then we start to put in lines of, right, well, this is these types of rule, and these are these types of rule. These chunks become the basis of its. So its inverted triangle CSS is an inverted triangle full of layers of different types of rule, which are basically written in specificity order. So basically, looking at the problems with CSS and the problems with us, we need a sane environment that's accessible to lots of people. You know, an entire team needs to be able to know where to look to find rules and where to add new ones. Tame and manage source order, get rid of the redundancy, create a place for everything to live. Like I say, if someone comes along and needs to find out where all the helper classes are, they know they can grab them from a certain place. When they add a new feature, they need to put it in a certain place again. Reduce waste and redundancy and end the specificity wars, and this is where it comes in. Or as I'm halfway through the talk and I've not even mentioned the architecture yet. So yeah, it stands for inverted triangle CSS. It's a really high level, very simple diagrammatic way of looking at your CSS projects. The triangle represents an entire site's worth of CSS. So whether that's compiled out of a preprocessor or whether that's just vanilla CSS, the triangle represents all of it. One thing I've noticed about a lot of methodologies is they try and avoid CSS's tricky parts. You know, they try and avoid specificity completely or try and avoid the cascade completely. That's often counterproductive and not always that useful to us. In certain cases it definitely is, but for most projects we can't avoid the fact that things cascade and inherit. So what it tries to do is point them in the same direction. It tries to get them working to our advantage. And as I've said, it's a sane, scalable, managed architecture. Nothing to do with what code you actually write, it's just the order in which you write it. And the diagram looks like this. It's an inverted triangle split up into X amount of layers. We've got a default amount of layers, which I'm going to cover. But depending on your project, you could have any amount of layers in there. It depends what you need. Like I say, it's a very malleable architecture. And what it does is this orders our project from very generic types of rule, really generic low-level things like resets, to very explicit rules, trumps and overrides and helper classes at the tip of the triangle. It orders from far-reaching to very localized. So the first types of rule you have in your project would affect a lot of the DOM. And the rules at the bottom of the project only affect a little bit of the DOM. That's where we get the triangle from. The triangle shape comes from the size of each layer affects that representative amount of the rest of the project. And of course, going back to what we said about the specificity graph, low specificity selectors at the top, your star selector, resets, that kind of thing, and then high specificity selectors at the bottom. So helper classes with important flags on them. And the layers by default are settings, tools, generic, base, objects, components, and trumps. If you use a preprocessor, you will need the top two layers. If you don't use a preprocessor, bin them. If you work in an object-oriented CSS manner, anyone work to an OOCSS methodology? So a few of you will need the objects layer. Those of you who don't can perhaps ditch it. And the default layers, so settings is global variables. These are things that operate globally. You might have private variables inside specific partials, but your project's global variables go right at the beginning. Tools, so default mixins, helper functions, that kind of stuff. Again, globally operating, globally available, they come next. Generic, I call them ground zero styles. These are kind of styles that prepare your project for actually doing some work. You've got a reset in there, you've got normalize.css, perhaps you've got global box sizing. These affect a lot of the DOM, but they're very low specificity, so they come into the third layer of the triangle, which is actually, if you use a preprocessor, the generic layer is the first layer that will produce any CSS. The base layer, unclassed HTML elements. So these are called type selectors, which is a little confusing because it doesn't necessarily have anything to do with typography. A type selector is simply an H1, or just an HTML element selector. Lower specificity than class-based stuff, which comes next. So objects, design-free, design patterns. Then components, so this is where you would have a carousel. This is a distinct piece of UI. You might have a flyout nav, you might have an accordion, right? A distinct piece of UI. So as you go down this list, you can see that specificity is slowly increasing. We've got really generic rules. Then we've got HTML element selectors. Then agnostic class kind of things. You'd use classes for your components, so like dot widget, dot gallery, dot carousel, that kind of thing. And the last layer is trumps. These are helpers and overrides. So each one in a little more detail then. Like I said, globally available. You will have settings, if you use a preprocessor, you'll probably have settings all throughout your project, but only a few will be globally operating. So you put these at the beginning. They need to be available to the rest of the project. There's no point having your brand variables at the bottom of a project because they'll be inaccessible. This is a really obvious one. This has to go first. And yeah, it could be stuff like color variables, spacing units held in a variable, stuff that you might want to use globally throughout the rest of the project. It's in the top layer because it affects the most of the project. The tooling layer. So I have a series of math helper functions, which will halve a number, then round it to the nearest pixel. These are globally operating helpful functions. They have to come after settings because they might take one of your variables as a default parameter, but they have to come before the rest of the project if you actually want to use them. Again, another really obvious place for this layer. And this could be like a font size, a font style mixin. So the generic layer, the first layer that produces any CSS. Ground zero styles, low specificity, very far reaching. We have it here because you couldn't really put your global box sizing at the end of a style sheet. You'd want that first because it cascades to the most of the project. We put it in quite a wide layer. Resets, normalize, that kind of stuff, really low level styling. Perfect example would be the star selector. It affects all of the DOM, so it goes in quite a wide layer. The width of the layer basically represents how much of a project that layer can affect. Yeah, the base layer, unclassed HTML elements. What does an H1 look like without a class on it? You know, as soon as I drop a P element into a page, what would I expect it to look like? So these are just element selectors. Slightly more explicit than the generic layer, slightly more specific, so the specificity of an H1 is slightly more than the universal selector, and it affects less of the DOM. It's every type of H1. So the generic layer says every element in the DOM, and this layer says just all the H2s in the DOM. UL list style square outside, right? Really low level, but quite, or certainly more explicit than generic styles. If you work in an object-oriented fashion, you'd have your design patterns in this layer. So if you use object-oriented CSS, you would have the media object, perhaps. The example I've got here is a very agnostically named UI list. And this is the first layer we'd begin using classes. Because we have to maintain the upwards trending specificity graph, this is the first layer we introduce a class-based selector. Everything before it should be a lower specificity. Agnostically named then, the objects layer needs to be useful on all sorts. This is just a general UI list design pattern. It could apply to anything. It doesn't really describe the content or function whatsoever. And you can see here we're using some of our settings. This is chased up by the components layer. This is where this layer is still class-based, so we haven't introduced any more specificity, but we have got more explicit. So the UI list might be a certain permutation. You might have 10 UI lists on a page, but one of them might also be the products list. This layer is smaller because it affects less of the DOM, but it's more explicit than the layer previous. So yeah, the products list might extend the UI list, and it's using, again, some of our default mixins and variables. So what you should see is as we go down this inverted triangle now, the order in which we're structuring our entire project is lending itself very, very well to just bolting new bits on in the right area. It's keeping the specificity graph trending upwards, we're avoiding the specificity wars, and slowly getting more explicit until we get to the very bottom, where we get the trumps layer. Now the trumps layer is overrides, it's helper classes, it's utilities. These might only affect one bit of the DOM at a time, like a hidden class that you toggle with JavaScript. Only affects one bit of the DOM at a time. It might have it important on these rules because you want them to win. The name actually comes from Top Trumps. Do you have the game Top Trumps? Yeah, that explains the blank faces. So I may need to internationalize this layer a bit more, but Top Trumps is basically a card game that typically children play. And all you have to do is have a higher number on your card than your opponent. There's no skill involved, it's not an elegant game, it's just all about winning by virtue of having a bigger number. Trumps are just winning out, right, through just sheer brute force. The trumps layer is what this layer does. It trumps everything, it wins just by virtue of having higher specificity. So it could be .1/2, right, some width helper classes. It could be your clearfix class, so .clearfix would typically have a lot of importance on it because you're using that class because you want to clearfix something. You want it to win out. So helper classes usually have important on them. Okay, so I need to start hurrying up a bit. You should start to notice that specificity slowly increases layer by layer. So the specificity graph is trending upwards. Each layer you go down the project, specificity gradually increases until you get a sharp point at the end where you've got all your importance. If you were to have those importance at the beginning of a project, a lot of people include helper classes early on in a project because it feels quite frameworky and global. The problem is that spike in the graph would be right at the beginning of your project now. And you can see where you're going to hit the specificity wars by having very high specificity selectors very early on. We affect smaller and smaller bits of the DOM as we go down a layer. That's why it's a triangle. The layer width denotes how much of the project you can affect. And we progressively add styles, which gives us this kind of sort of model. The previous up and down and erratic way of styling, we've now replaced it with a much more layered approach. We're progressively extending each previous layer. So the amount of redundancy, the amount of undoing CSS, the amount of things we backpedal and try and undo is completely reduced. If we would take the triangle and look into it like it's an ice cream cone, we would find that the top layer, the top ring, affects a lot of the project or a lot of the DOM, and so on until you get right down to the bottom and you're just affecting one bit at a time. So the triangle forces you to write CSS so that your cascade really nicely trickles. You don't have a really far-reaching selector right at the bottom of the style sheet. you've got all the wide stuff at the top and it trickles down. If you imagine how you would chase your styles through this architecture, it does trickle. It trickles to a point, and you haven't had to spend any of your time undoing anything or in the specificity wars. It's just a managed architecture. Okay, so I've got 11 slides left. It manages your source order, filters explicitness, tames the cascade, and sanitizes inheritance. It makes everything just a little bit more sensible, a much nicer environment to work in. Each layer is a pass over the DOM. Like I said about the concentric circles, each layer affects less and less of the DOM. It's like a pass, which means that each layer adds progressively more detail. This is a maintainable and scalable architecture because you can peel layers back as far as you need them, or you could add them on until you don't need them anymore. The outcomes are everything has a place to live. This is a really good architecture for teams because people know where to find certain rules. If I need to change the style of all the P elements on a site, I know it's in the base layer because I've chunked it up in a sensible, sane order. We've reduced waste and redundancy. The amount of undoing CSS is completely reduced. We don't have this skipping up and down the style sheet anymore. And we've not really looked at scalability. I'm going to have to really whiz through that. But we've increased our scalability or our ability to scale a project by virtue of just having a nicer environment, a more sane environment in which we're writing CSS. So scaling it. Now we can scale our code base much more easily. The amount of CSS in our project we can scale really simply because it's a case of just adding it more in the relevant layers. But we can actually scale the architecture itself, which is really cool. I've worked with clients who've needed different layers than the default 7, and we'll try and look at that now. So yeah, scaling our CSS, no longer the end of a style sheet problem to worry about. We add things into the relevant layers. Usually the later layers, you shouldn't really go back and change the style of all your P elements on a site once that site's 3 months old. That's far too far-reaching. You'll find that as you maintain a project, most of your work goes in the last few layers. Things never get complicated, only bigger. And the first complicated step is actually setting the triangle up. Once you've set the triangle up, it just grows in a well-rounded manner. You're not dumping all the complexity onto the end of a style sheet. The specificity graph keeps trending upwards, right? The baseline for it, the thing you should keep in mind when you're writing CSS in an its style inverted triangle manner, keep the specificity graph trending upwards. Okay, so scaling the architecture itself, add and remove layers as and when you need to. If you don't use a preprocessor, you don't need the first 2 layers. If you need a theming layer, put one in. The theming layer probably comes after the components layer. It's slightly more explicit than a component because it's like a skin on top of it, but it's not quite an override. So sneak a layer in. I did some work with Booking.com last year, and they run a lot of A/B tests. And one of the problems they had is that they'll write some A/B test CSS, and obviously one test will pass, but they would never get around to deleting the other CSS. So you'd have both tests worth of CSS in the project, but one wasn't getting used. So we decided that we could isolate that test CSS by having a test layer. Just before the overrides, we just put a layer in called test. It means that you can keep an eye on what's in there. It overrides other things perhaps, but it's easy to extract once you don't need it. So you can add layers exactly as and when you need to. So to quickly recap, this is the last slide as well. So just try and write CSS in specificity order. It's the simplest way to start writing a more scalable UI. Remove the chance of specificity wars by writing CSS in a way that specificity only ever increases. Maintain the specificity graph, basically. All rule sets should only ever add to and inherit from ones that have gone before them. As soon as you write CSS to undo CSS you've already written, that's a code smell. That's a sign that something has gone wrong. Order style sheets from far-reaching to very localized. This is where we get the triangle. And finally, add layers as and when you need to, but only in the relevant place. And you can work that out for yourselves. If you know that it needs to be a slightly higher specificity than the previous layer, you can work out in your own project, your own architectures, when new layers need to go. And that is it. Final slide. Thank you very much.